Hello everyone and welcome to a new lesson on geometric figures. I'm Jazmin Rodriguez.
Jessica Johnson.
Claudia Kemp.
Cece Rodriguez.
Ladies, I have a question for y'all today. What did the acorn say when it grew up?
What did it say?
Gee, I'm a tree. And I'm sure you can guess that's what we're going to be talking about today, so let's get started.
Jazmin, what is a complementary angle and can you provide an example?
Claudia, great question. First, let me tell you that two angles are said to be complementary when their angle measures add up to be 90 degrees. The angles don't necessarily have to be next to each other as long as they add up to be 90 degrees. In this first angle, we see that we have 90 degrees on one and that we have 30 degrees on the other one. When we add these angles up together, they will give us 90 degrees. Therefore, this is a complementary angle. On our second example, we see that we have two angles with two different measurements, and we see that they are not necessarily next to each other, but it doesn't matter as long as when we add them up, they equal 90 degrees. So 50 plus 40 is 90 degrees. Therefore, this is also an example of a complementary angle. And then for this graph that we are given, do we have a complementary angle? Well, if we try to add up any two numbers, for example, 58 plus 63 degrees is 121 degrees. And we see that we have no complementary angles in this figure. Claudia, there are so many unknown angles. How do we even begin?
A problem like this can be very overwhelming, so that is a great question. First thing you need to know is a little basic knowledge about triangles. Like a straight line, the three angles of a triangle, when added together, will equal 180 degrees. So for a problem like this, you would take the three main angles of the main triangle, 76 degrees, 31 degrees, and then angle 1, and you would take 76 and 31, add them together, which equals 107, and you would subtract that with 180, so angle 1 would be 73 degrees. Jessica, what are supplementary angles?
Claudia, I'm glad you asked. Supplementary angles are angles that sum to 180 degrees. When we have a straight line, the total degrees equals 180. When we know the degree of one angle, we can always find the degree of the other angle. Since we know that a line equals 180 degrees, we can take 180 degrees and subtract 110 degrees. And that makes angle 2 equal to 70 degrees. Cece, please explain to me what complementary angles mean.
Thank you, Jessica, for asking a great question. Complementary angles are angles that add up to 90 degrees. As you can see, 40 plus 50 would give us 90 degrees. This is also classified as a right triangle, as you can see. Jessica, when looking at triangle ACB, how would I solve for angle 5?
First, I want to explain what an angle is. An angle is a measurement in degrees in the space between two intersecting lines. To solve for angle 5, look at the segment CB. We already know that a line equals 180 degrees. Add together angles 4 and 6, which equals 100 degrees. Then take 180 degrees and subtract the sum of angles 4 and 6 to equal 80 degrees. This makes angle 5 80 degrees.
Cece, what are the measurements of angle 6 and 10, and what is it called when they are across from each other?
Yes, Jazmin. Thanks for asking a wonderful question. I'll explain exactly how this works. We could subtract 180 from 61 and get 119. Since angle 10 is similar to angle 6, meaning they are the same, that would also equal 119.
Claudia, how can we check our answers to make sure these numbers are correct?
Great question, Jessica. You always want to check your work. A great place to start is to ensure that all of the triangles equal 180 degrees as we discussed earlier. You would start with the top triangle, triangle CPQ, and you would take all of the found measurements for that triangle, and you would get 76 plus 73 and 31, which equals 180. And then the bottom right triangle, triangle QRB, has the same measurements, and so it's also 180. And then you would take the entire triangle as a whole, which again has the same measurements as 180. Now that you know that those numbers are correct, you can use what you know about relationships of angles to check the rest of the numbers.
Jessica, I'm curious, what is a reflex angle?
Jazmin, I'm so glad you asked that. After solving for y for all three angles, 3y, 7y, and 12y, by using algebra, we get the values of 3y equals 60 degrees, 7y equals 140 degrees, and 12y equals 240 degrees. Angle 12y is considered a reflux angle because its measurement is greater than 180 degrees, but less than 360 degrees. You can think of it like this. A reflux angle will be larger than a half circle of 180 degrees, less than a full circle of 360 degrees. As you can see, angle 12y is much wider than angles 3y and 7y.
Jazmin, what is the relationship between angles 2 and 7?
Easy. Thank you for that question. First, as we can see here, we have a parallelogram that was formed between angles 1, 2, 5, and 7. And a parallelogram is described as a polygon in which the opposite pairs of lines are parallel. That means they will never touch each other. So PQ is parallel to line AR. And it also means that our angles are going to be congruent, also known as equal. So as we can see, our angle 7 is on the opposite side of angle 7. That means that whenever we look at these two, they are going to be congruent angles and they will have the same measure.
Cece, looking at the triangle, how do you find the measurement to angle 4?
Great question, Claudia. As we can see, we are given a triangle. Let's look at the top triangle. Triangle CPQ. What we do is we have to add up 74 plus 80, which will give us angle 4, giving us 26 degrees. Claudia, are polygons similar to triangles in which all the angles add up to 180 or another number?
I like your thought process there, Cece, but it's not exactly how it works with a polygon. With a polygon, instead of it being a set number, it's a set equation. N minus 2 times 180, where n is the total number of sides of the polygon. Taking this one, for example, there are 8 sides, so it would be 8 minus 2 times 180, which equals 1,080 degrees.
Jazmin, what is the difference between a concave and a convex polygon?
Jessica, excellent question. I know these two can get a little bit confusing. First, let me explain what is a polygon. A polygon is formed when you connect a series of line segments together, like we have done in both of our shapes here. Now, for a polygon to be convex, we will use an example as we will put 2 points in our polygon and we will try to connect them with a line segment. When we connect them, we see that our line exits our shape. Therefore, this is going to be a convex polygon. Now, when we're talking about concave polygons, we will do the exact same thing and we will put 2 points in our polygon and we will connect it with our line segment. And then as we can see, our line never exits the shape. Therefore, this is going to be a convex polygon.
Cece, in the given concave polygon, how do we find y?
Excellent question, Jessica. Let's get started. We have to count the number of sides this polygon has. In order to get that, we count each individual size for the complete shape. We also know we notice that we have 8 given sides. We also know the equation is n minus 2 times 180. So since there are 8 sides, we plug that number in for n. This would look like 8 minus 2 times 180, giving us 1,080. Now let's find the y's. We add up all the 3 y's, the 7 y's, and the 12 y's, giving us 54 y's equals 1,080. We're trying to get y by itself, so we divide 54 on each side, giving us y equals 20.
Jazmin, what is the central angle in this nonagon and how do you calculate its measure?
Awesome. Thank you for that, Claudia. Let me tell you, a central angle is any angle with a vertex at the center of a polygon whose adjacent sides meet at the vertex, which is at the top. Now, in order to find what the measure of our central angle is, we are going to be using our formula that is 360 degrees divided by n. N represents our number of sides in our polygon. As we can see, this is a nonagon which has 9 sides. So we will simply plug it into our formula and it will give us that our central angle is 40 degrees.
Jessica, what are interior angles inside of a polygon?
Cece, I'm so glad you asked. Interior angles will be inside the polygon. There are 9 interior angles on this polygon, making it a nonagon. The interior angles are at 2 adjacent lines connecting to share a vertex. These 2 lines connecting are adjacent lines, and this is the vertex where 2 adjacent lines connect.
Cece, is this an exterior angle?
Excellent question, Jazmin. Yes, in fact, this is an exterior angle. And exterior angles are angles that are formed outside of the shape. In this example, it is a small triangle or angle where the arrow is pointing to outside of the given polygon. The prefix x means out of. In this case, it's referring being outside of the polygon. This is, in fact, an exterior angle.
Excuse me.
Claudia, how do we know which lines are parallel again? And how do we know a good way to remember these?
That is a good question, Jessica. It's really good to make sure you understand this concept and that you can identify it. Parallel lines are 2 straight lines that no matter how long they go, they are always an equal distance apart from one another, meaning they never touch no matter how far into infinity they go. You can see here to the right that lines 1 and 2 are parallel. However, the other 2 lines are not because they intersect at the top. An easy way to remember this is to look at the word parallel. When written in print, it actually has 2 parallel lines with the 2 L's.
Thank you, Claudia.
Can you tell me, Cece, in the given interior angle polygon, how you find the measurement?
Of course, Claudia. The interior angles are angles that are formed inside the polygon. In this case, it is where the arrows are pointing to each sides. This is, to find the measurements, we would use the equation n minus 2 times 180 divided by n, where n equals 9. As we can see, n minus 2 times 180 divided by 9 equals 140 degrees. Jazmin, what is a tetrahedron?
Cece, good thing you asked. Let me tell you. A tetrahedron is a polyhedra with 4 equilateral triangles. That simply means that all sides are going to be equal. A tetrahedron is also referred to as a triangular pyramid. The pyramid, of course, begins with our base and, of course, our faces that will end up meeting at the top of the apex. Now, the apex is going to be the highest point above the base of our pyramid.
Cece, which of the following formula do we use for the central angles?
Great question, Jessica. Well, we all know that central angles are angles that form inside the polygon, or the shape. In this polygon, we can see that where the big middle triangle is. The triangle in the middle is referred as the center. This is why it's called central angles. In order to find that measurement, we would use the formula 360 divided by n, where n equals the number of sides of the polygon, and 360 is what the whole shape adds up to. Therefore, 360 divided by 9 equals 40.
Looking at the figure, how can I know that there is a tetrahedron inside the cube, Jessica?
Claudia, I'm so glad you asked that question. A tetrahedron is really a cool 3D figure that has 4 equilateral triangle faces, 6 straight edges, and 4 vertices. Think of a tetrahedron as a pyramid. Back to the tetrahedron inside the cube here. This is the face 1, and it lies along the left side of the cube. This is the face 2, and it lies along the back side of the cube. This is the face 3, and it sets up on top and runs through the middle of the cube. This is the face 4, and it lies on the bottom of the cube.
Cece, how many straight edges does a tetrahedron have?
Great question, Jazmin. I'm glad you asked. A tetrahedron has 6 straight edges. As we can see, each arrow is pointing to all the straight edges inside the given triangle. If we were to add them all up, we would end up with 6 straight edges.
Claudia, what are vertical angles and how do we identify them?
Vertical angles are actually really easy to understand, Jessica. They're angles that are opposing one another across straight intersecting lines. As you can see here, if the lines are not straight, then they're not vertical angles. A great thing and easy thing about vertical angles is that they are always equal to one another. So we can see the angles 1 and 5 are vertical, just as our angles 9 and the angle measures 61 degrees. And since they are vertical, we can know that angle 9 also measures 61 degrees.
Jazmin, which of the following figures represents an icosahedron?
Cece, thank you for that question. First, let me tell you that an icosahedron is represented as having 20 faces, 12 vertices, and 30 edges. Now, when we are going to identify this, when we talk about the faces, we are talking about the single flat faces of our shape. When we're talking about the vertices, we are talking at the points at which our figure meets. And then when we're talking about the edges, we're going to talk about the line segments that connects this. So as we can see, for example, in our middle diagram, we have 4 faces. If our icosahedron has to have 20 faces, this would not be it. If we look at our figure on the left, this one is going to have 8 faces. Once again, we know that's not going to be our icosahedron. Now, lastly, we can see that this one has our 20 faces. If we count, we'll have 12 vertices and our 30 edges. Therefore, this represents an icosahedron.
Cece, can you tell me which of the following has 12 edges, 6 vertices, and 8 faces?
Of course, Claudia. I will explain to you. Let's start with letter A. As we can see, letter A has 4 triangle faces, 4 vertex corners, and 6 straight lines. This is a tetrahedron. Let's look at letter B. We can see that it has 12 vertices, 30 edges, and 20 equilateral triangles. This is an icosahedron. Let's look at C, where C has 12 edges, 6 vertices, and 8 faces. Claudia, therefore, it would be letter C.
Awesome.
Jessica, what is an octahedron?
Thank you for asking. Let's break the word down. Octohedron. Octo equals 8. And hedron means side of a polygon. This word literally means 8-sided polygon. Think of an octahedron as two pyramids stuck together at the base. Octahedron has 8 equilateral triangle faces, 12 edges, and 6 vertices. How many vertices does an isohedron have?
Thanks for asking, Jessica. Let's begin what an icosahedron is. It is a polygon that has 30 edges and 20 equilateral triangles and 12 vertices. How do we know what vertices are? Vertices are common endpoints of 2 or more rays. Therefore, it is 2 lines that are formed of vertex joining at one point. As you can see, each arrow is pointing to 12 vertices. What are scalable diagrams? Scaly.
Great question with no easy answer, Cece. Schlegel diagrams are named after German mathematician Victor Schlegel, who introduced the diagrams to the mathematic community in order to help people study and to understand concepts involving shapes and structures. Basically, the diagrams are a way of two-dimensionally depicting a three-dimensional or four-dimensional shape. For example, with these that we have here from the homework, we can see that the one on the far left looks like it only has 3 sides, but we know that it's supposed to be three-dimensional, so it actually has 4 faces, one being on the bottom. And then the same in the middle, it looks like 19, but we know that it has 20 because it's three-dimensional. And then the one on the right looks like 7, but actually has 8 because it's a two-dimensional figure representing a three-dimensional figure.
That's the end of our presentation. I hope you enjoyed learning about geometric figures. Thank you.